Hello, myself K. Rajini Suresh, lecturer in Metallurgy Department in Sanjay Gandhi Polytechnic College. So, in this session, let's know the subject iron making. Iron making, it is the process of production of iron. In this subject, let's know the second unit, modern blast furnace plant and process. So, today's contents are mantle and column, stack, tuya and bus slip pipe. So with respect to furnace details, let's know about mantle and column, stack, tuya and bus slip pipe. Very first, mantle and column. Where it will come actually, it is above the Bosch level. Above the Bosch level, we will find mantle and column. The furnace above the Bosch level is supported on a heavily braced steel ring. Above the Bosch level, there is a support is given of heavily braced steel ring which is embedded in the foundation. So, encircling the furnace wall, furnace top of the Bosch is called as mantle. Above the Bosch level ಮೇಲ್ಗಡೆ peripheral wall ಮೇಲ್ಗಡೆ this heavily steel ring ಅನ್ನು ಸಪೋರ್ಟ್ ಕೊಟ್ಟಿರ್ತಾರೆ. ಆ ಸಪೋರ್ಟ್ ಅನ್ನ ಫೌಂಡೇಶನ್ ಅಲ್ಲಿ is supported uniformly spaced upright heavy columns into the foundation. So heavily braced steel ring is mounted onto the Bosch above the Bosch level. It is called as mantle and which is supported uniformly upright, spaced upright, heavily braced columns. So it is called as mantle and column because it has to withstand the height of the furnace. To firm withstanding of the furnace, the support has given above the Bosch level because it is too tall, around 30 meter height. So to give support for the blast furnace, this mantle and column facilities has been made above the Bosch level. It is constructed with the help of heavily braced steel ring and which is encircled in the furnace top of the Bosch is called as mantle and is supported uniformly spaced upright heavy columns. Next, stack. Stack is a huge cone mounted on the mantle and extends to the top of the furnace. Here this zone is known as stack. It is a frustum of huge cone. It is just like a parallel shaft construction and which is all over the blast furnace. The blast furnace is welded steel plate construction and inside beneath that refractory lining is done. Beneath the both refractory lining and the steel shell, there is a water cooling facilities has been made. The water is circulating into the copper cooled copper plates. Water cooled copper plates has been assembled. In the copper plates, water is circulating. Water won't come in contact. It is surrounded all over the furnace beneath the steel shell. So stack, it is a huge frustum of huge cone and which is mounted above the mantle and extends to the mantle ಮೇಲ್ಗಡೆ place ಮಾಡ್ತೀವಿ top ವರೆಗೂ extend ಆಗಿರುತ್ತೆ. The stack is welded steel plate construction. Stack is welded steel plate construction lined by fire bricks. ನೋಡಿ one thing, Hearth ಅಲ್ಲಿ carbon blocks, Bosch ಅಲ್ಲಿ carbon blocks is coated with the graphite and all over the Bosch level you will find out the carbon blocks only. But above that Bosch, ಇಲ್ಲಿ temperature ಕಡಿಮೆ ಇದೆ, 200 ಲಿಂದ 900 degree Celsius temperature ಇರುತ್ತೆ stack zone. So here we don't require a heavy and good quality of refractory lining. We can make use with the help of bricks lined only, fire bricks only. So fire bricks are assembled here at the top portion of the stack because the high temperature and these refractory lining is the stack line is protected. The refractory lining in the stack zone are protected from the abrasion by armor plates on the inner surface of lining. ಏನಾಗುತ್ತೆ ಇಲ್ಲೆಲ್ಲ ಚಾರ್ಜ್ ಪಾರ್ಟಿಕಲ್ ಎಲ್ಲ ಮೇಲ್ಗಡೆಯಿಂದ ಹಾಕ್ತಾ ಇದೀವಿ ನಾವು. We are charging the raw material like ore, iron ore or pellets, iron ore plus pellets, coke, which will be the iron ore size ಆಗಿರ್ಬೋದು, coke size ಆಗಿರ್ಬೋದು, limestone size ಆಗಿರ್ಬೋದು, +30 to -50 mm ದಪ್ಪ ಸೈಜ್ ಇರೋವೆಲ್ಲ ಹಾಕ್ತಿರ್ತೀವಿ ನಾವು. ಸೊ ಅದಕ್ಕಾಗಿ ಏನಾಗುತ್ತೆ, ಇಲ್ಲಿ ರಾ ಮೆಟೀರಿಯಲ್ ಹಾಕ್ತಿರ್ಬೇಕಾದ್ರೆ ತೆರ್ಕೊಂಡು ರಿಫ್ರಾಕ್ಟಿವ್ ಲೈನಿಂಗ್ ಎಲ್ಲ ತೆರ್ಕೊಂಡು ಇಟ್ ಮೇ ಎರೋಡ್ ಇಟ್ಸ್ lining life. So to avoid the erodence of the refractory lining in this tag zone, it is protected from the abrasion resistant by armor plates. Armor plates are assembled. Armor plates are assembled inside the surface of the furnace lining. Okay, this is about the stack, and it is a system of huge cone. Here we will maintain minimum temperature around 200 to 990 degrees Celsius. It is constructed with fire bricks, and it is saved by abrasion resistant with the help of armor plates. Next is tuyo and buslip pipe. Here in this picture clearly you can find out the tuyers. These are the tuyers. However, you can spell tire or tuyers, and these tuyers are connected with a huge buslip pipe which is encircled all over the peripheral wall of the furnace. Here you can find the assembly, how the tuyers are assembled, their nozzles, and how does looks like the buslip pipe. This is the buslip pipe, huge buslip pipe which is surrounded, encircling peripheral wall of the furnace. In tuyer zone, through which hot air blast is blown for fuel combustion. So tuyer zone alli ಏನು ಮಾಡ್ತೀವಿ ನಾವು, preheated blast of air ಅನ್ನು ಕಳಿಸ್ತಾ ಇದ್ದೀವಿ. Around 1200 to 1300 degrees Celsius temperature is maintained in of the preheated blast of air. This air is preheated into the stove. Through the stove, buslip pipe is connected to the blast furnace, which is surrounded, encircled all over the peripheral wall of the furnace, and these tuyers are connected into the furnace within tuyer nozzles. Through this nozzle, preheated blast of air is injected into the blast furnace under pressure around 1200 to 1300 degrees Celsius temperature of the air is maintained. In tuyer zone, through which hot air blast is blown for fuel combustion. Coke hatkondu uriyutte. So the number of tuyers vary with the size of the furnace. So these tuyers are varies with the size of the blast furnace. Blast furnace ಎಷ್ಟು ಇರುತ್ತೆ ಅದರ size ಮೇಲ್ಗಡೆ number of tuyers are varied. Maybe around 18 to 20 tuyers are assembled all over the peripheral wall of the furnace, which is connected to the huge buslip pipe. Usually 10 to 20 are distributed uniformly spaced all over the peripheral wall of the furnace. This is how the assembly looks like. Did you got? These in front of the tuyers, inside the furnace, in front of the tuyers, there is runways and raceways are located. Through that runways and raceways, very first the air takes horizontal, next it will takes to the vertical direction. First horizontal agi move agutte, aamele vertical direction ge hogutte gaali, coke hatkondu udanta gasಗಳು. So runways and raceways are assembled in front of the tuyer zone itself. This is about tuyer and buslip pipe. Multiple choice questions. The furnace above the Bosch level is supported on a heavily braced steel ring, B circular egg section, C circle, or D pipe. The furnace above the Bosch level is supported by the heavily braced steel ring. Already we have been discussed. This steel ring, heavily braced steel ring, into other belagade matte construction irutte stack zone. So these steel rings are firmly embedded in the foundation. Okay, the correct answer is heavily braced steel ring. Stack is frustum of dash mounted on the mantle and extends to the top of the furnace. Stack, it is the frustum of huge cone. Nodi stack zone alli construction nodi alli conical shape parallel construction irutte. It is not wider, it is not high diameter ella iralla. So shaft, it is the frustum of huge cone. It is just like a shaft construction, but it is frustum of huge cone. It is not tubular. None of the above. It is not the proper answer. The proper answer is huge cone. Okay. Next. Stack is welded steel plate construction lined from inside. Hard fire bricks is protected from abrasion caused by the falling charge by providing armor plates, graphite coating, slag layer. None of the above. already we have been discussed with respect to stag zone. ಅಲ್ಲಿ ಟೆಂಪರೇಚರ್ ಕಡಿಮೆ ಇರೋದ್ರಿಂದ ಏನು ಮಾಡ್ತಿದ್ವಿ, ಫೈರ್ ಬ್ರಿಕ್ಸನ್ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಆಮೇಲೆ ರಾ ಮಟೀರಿಯಲ್ ಎಲ್ಲ ಬಿಡೋದ್ರಿಂದ ಏನಾಗುತ್ತೆ, ರಿಫ್ರಾಕ್ಟಿವ್ ಲೈನಿಂಗ್ ಲೈಫ್ ಕಳ್ಕೊಳ್ಬಾರ್ದು ಅಂತೇಳಿ ಅದಕ್ಕೆ ಆರ್ಮರ್ ಪ್ಲೇಟ್ಸನ್ನು ಅಟ್ಯಾಚ್ ಮಾಡಿರ್ತಾರೆ. ಸೊ ಸ್ಟ್ಯಾಗ್ ಈಸ್ ವೆಲ್ಡೆಡ್ ಸ್ಟೀಲ್ ಪ್ಲೇಟ್ ಕನ್ಸ್ಟ್ರಕ್ಷನ್ ಲೈನ್ಡ್ ಇನ್ಸೈಡ್ hard fire bricks is protected from the abrasion resistance caused by the falling charge, providing armor plates. Graphite coating it is given in the Bosch zone for the carbon blocks. Carbon refractory lining ಏನು ಹಾಕಿದಾರಲ್ಲ ಅದಕ್ಕೆ ಕೋಟಿಂಗ್ ಕೊಟ್ಟಿರ್ತೀವಿ to withstand the high temperature of the furnace and liquid metal and slags. But it is not a protective layer for the falling charge material. It is the armor plate which will protect the falling charge material abrasion resistant. Slag layer, it is also makes in the Bosch zone for the carbon blocks. Bosch zone ಅಲ್ಲಿ ಇರುವಂತ ರಿಫ್ರಾಕ್ಟಿವ್ ಲೈನಿಂಗ್ ಗೆ ಒಂದು ಲೇಯರ್ ಫಾರ್ಮೇಷನ್ ಆಗಿರುತ್ತೆ, ಯಾಕಂದ್ರೆ ಎಲ್ಲ ಲಿಕ್ವಿಡ್ ಸ್ಟೇಟ್ ಅಲ್ಲೇ ಬಂದಿರುತ್ತೆ. ಅಲ್ಲಿ ಸ್ಲಾಗ್ ಲೇಯರ್ ಕೂಡ ಒನ್ ಆಫ್ ದ ಕೋಟಿಂಗ್ ಇರುತ್ತೆ. ನನ್ ಆಫ್ ದಿ ಇಟ್ ಇಸ್ ನಾಟ್ an answer. The proper answer is armor plates. Next, two are connected with the one huge single pipe. What is that? Tuyas are connected with a one huge single pipe, whether it is circular pipe, burst pipe, wind box or manifold. It is a circular pipe, but it is bustle pipe. It is a bustle pipe which is connected, huge single bustle pipe is encircled all over the peripheral wall of the furnace. This is the perfect answer. Next, in front of each tuya exist what? Runways and raceways, channel, passageways, none of them. So channel, it is to be done in front of the tap holes to tap the molten metal and molten oxide slag comes through that channel and separates with the help of skimmer arrangements. Slag will separate and molten metal will separate through that channel. But it is not the in front of the tuya. It is comes in front of the outside of the tap holes. Passageway is no way. So the correct answer is runways and raceways. In front of the tuyas, there is an assembly made runways and raceways. And the total efficiency of the blast furnace, which is totally dependent upon the thermal efficiency of the blast furnace. This thermal efficiency can be maintained by the pre-heat blast of air pressure and temperature and its circulation all over the blast furnace. If permeability is good, so which will gives the facility for the circulation of gases all over the blast furnace. Next, temperature in tuya zone is referred as raft, that is raceway adiabatic flame temperature. Raft in front of the blast furnace. Hot blast temperature, none of the above. The temperature in the tuya zone is referred as raft, raceway adiabatic flame temperature. Already we have been discussed, there is temperature has been maintained. The total efficiency of the blast furnace, it is totally dependent upon the flame temperature. So the flame temperature can be maintained by pre-heat blast of air and its temperature and coke burning. So total thermal efficiency of the blast furnace is dependent upon the raft, raceway adiabatic flame temperature. Bustle pipe. Bustle pipe is associated with copper stove, dust catcher, ESP. So the bustle pipe which is connected with the copper stove, the pre-heat blast of air from the stove will comes along with the bustle pipe and which is circulated encircling all over the peripheral wall of the blast furnace. That is bustle pipe, through which tuyas are connected. Around 10 to 20 tuyas are connected through to the blast furnace, and pre-heat blast of air is to be injected into the blast furnace with pressure and high temperature. Dust catcher which is connected with the downcomer, ESP and dust catcher, these are the gas cleaning system. Thank you. Our program coordinator, moderator, Mr. Gauri Shankar Hiremat, Principal, Sanjay Gandhi Polytechnic, Ballari. Myself, K. Rajini Suresh, Lecturer in Metallurgy Department, Sanjay Gandhi Polytechnic, Ballari. Thank you.